Okay, so review 5 is going to be pretty long. I'm going to go through and basically explain the ones that have the answers. The ones that don't have answers, I'm going to go through and work them out. Only a little bit irritated because I have done these before, but without fail, some students look at my past reviews and some students don't. So I'm just going to go over them again, and that's okay because that's what I'm here for. All right, so this is technically review 5 for the Summer Bridge program, and let's dive into it. Okay, this first problem is what I would consider a number sense problem. It says, what value does digit 8 have in the number following? So you just want to see what makes sense here. So hundreds, thousands, millions, next would be billions. So they are correct. Trillions is an option, but it makes most sense for it to be 80 billion. Okay. Second one here is a property problem. It says the expression 2,362 times 1 is equal to 2,362 because of what? The multiplication property of 1. Okay. Use the number line to determine which of the following statements is true. You have 4 points on the number line. This one here says the value at point R is greater than the value of Q. Well, Q is to the left of R, so that makes sense. R would not be greater than S because S is to the right of R. And S is very much to the right of P, so it cannot be less than P. And S cannot be less than Q because, again, S is to the right of Q. All right. On a number line, where is the number -1 in relation to number -7? Well, -1 is to the right of -7. So let's go back and look at that number line. If we pretended all these were negatives, which obviously 0 would then be, well, I guess we can't do that. Let me just write you a new number line. Okay, so if we have a number line 0, -1, -2, -3, -4, -5, -6, and -7. Again, you can now verify that -1 is to the right of -7 on the number line. Find the opposite of the absolute value of -4. Well, to do that, you first need to realize what does the absolute value of -4 give you? Well, the absolute value of -4, that's asking you how far away from 0 is -4. Well, luckily we have our number line here. Here's 0. If we count -4, 1, 2, 3, 4, that's 4 spaces away from 0. So it's essentially asking you, what is the opposite of the absolute value of -4? So what is the opposite of 4? That would be actually -4. Okay, so that one is a bit of a tricky problem. Here it says which pair of numbers are not opposites. Again, if you use the same rationale, not opposites, meaning you want the same number. Well, 47 and -47, those are in fact opposites. 74 and -74, again, opposites. The absolute value of 4 is 4, and then a -4, that again is opposites. The absolute value of -47 is just 47 away from 0. So those are the not opposites, that last one down here. Okay. All right. This is a little bit of an algebra problem. You can actually write it as an algebra problem. So it's saying, what's the absolute value of 6 equal to x? Well, you need to ask yourself, what would you get out for that answer then? So you would get 6 out as the absolute value of 6. So x is in fact 6. That is a 6 not a letter B, is a 6. Okay. A little bit nice that they wrote it like that. All right, what is 20,602 in expanded form? Well, you take your 20,000, you would then take 600, and you would take 2. And of course, you're adding those. So you can see why we would pick that one. Okay, now, I believe those are all the ones where the answers are given. There might be some later on where we might have to go back into more of an explanation, but let me first start working some of these out for you. Okay, so for this question, it's saying estimate the following by rounding to the nearest 100. So here you're going to look at the tens because we are rounding to the nearest 100. Well, both of those numbers are less than 5, so we're actually going to leave everything and then replace with zeros after the hundreds place. So basically 85 minus 33 will give you 52, and don't forget to add your zeros. So that is your answer there. All right. The next one is saying that they want you to round to the nearest 100. Again, you want to look at the tens. Here, we actually notice that we're going to round the first one, and then we leave the second. Some people see that as rounding down, whichever way makes you happier seeing it. And then I believe since it says what choice correctly compares the rounded numbers, you should do a inequality sign. Okay, next. All right, so I was a little bit mistaken. Here's some more that we just have to talk about. Which of the following equations is true? Well, 7 times 1, of course, will give you 7, and 0 plus 7 will also give you 7. 3 plus 1 does not give you 3 or 0, it gives you 4. So here we have 7 equals 7, that checks. We would have 4 equal to 0, that is wrong. 2 equal to 1, again, that is incorrect. And 6 times 1 times 0, that would be a 0, equal to a 6 plus 1 plus 0, so that would be a 7, again, incorrect. All right, which number is not equal to one of the following expressions? So here we would add a 0, so it'd be 1, 5, and 3 zeros. So 1, 5, and 3 zeros gives you that one. Here we're getting rid of 2 zeros, so that's going to be 1, 5, 0, 0. That's right here. And here we're getting rid of 1 0, so that's 150. So all of them are represented except for this one. Okay, if I'm going too fast, remember in the video you can just pause. All right. Match each expression on the left with the equivalent expression on the right. Some may not be used. This is just expressing your options differently. So basically the association property or associative property. So here you can see the 2 now goes to the outside and you're grouping 8 and 7. Those are identical, okay? Yes, the parentheses are different, but your outcome is going to be the same. Same here with 2 plus 7 plus 8, 8 plus 2 plus 7. Same thing, just a different order. Here they are taking and doing 5 times 3 times 12, and then they're changing it to 12 times 5 times 3. Again, the same. 3 plus the quantity of 5 plus 12 versus 3 plus 5 plus 12. Again, different grouping, but same answers. The one, of course, the 2 not being used, of course, would be this one. And this one, you could make up their matches in a way. But you would have to do something called distributed property for this one. You would just write it as 7 times 8 plus 2, or you could do 7 times or 7, 2 plus 8. Okay, this one I mean, really the only thing you can do is you could do 3 times 12 and then plus 5. That would really be the only options there. The second part here is working with square roots. So basically, if you were to rewrite this, you would rewrite it as the square root of 2 squared, and then square root of 10 squared, square root of 7 squared, and square root of 8 squared. Now, if you didn't know those right away, what you could do is you could come over here and you could say, oh, okay, these are my options. What happens when I do 2 times 2? Well, when I do 2 times 2, I get 4. So that's how you know those two match. And then you could do 7 times 7. Well, then I get 49. Okay, so are we seeing the pattern here, how we should work these? If you can't figure it out on this side, then come over here and figure it out on this side. So 8 times 8 equals 64. And I will tell you, as you continue, you should no longer really be using this old style of multiplication as that X there, because as you continue, you're going to be doing more algebra, and algebra is where we use a big period like that, kind of like a dot, and that's going to be your new multiplication sign, because that X is actually going to represent the unknown. So just keep that in the back of your mind. Okay. All right, we're about halfway through. We're going to do some simplifying. What we want to do here is the square root first. Well, we just learned that the square root of 100 is 10. So 10 minus 8. We're going to do that part. That 10 kind of reminds me of that melting clock painting. I forget which artist did that, but there you go for you artsy people. So 2 cubed, and we still have to remember we have this times 5 out here. So, and then 2 cubed is 2 times 2 times 2, so that's 8 times 5, and that's going to give us a 40. Sorry, in my work, I definitely wrote a 6 down. See, this is why you can't be sloppy when you're writing. So I ended up getting the wrong answer at the end, but it is a 40. Okay. If this was a regular class, I would let you guys research for me who did the melting clocks, and you might get a bonus point on your test, but this is not a normal class, so sorry. All right, so we're going to do what's inside first. So 10 minus 3, that becomes a 7 squared. Rewrite our minus 6, our plus 2. Now here, you could do this second part here. You can do that all in one. It kind of depends on how, eventually with these orders of operations, you'll get really good and you can do multiple steps at the same time, as long as they don't affect one another. So keep that in mind. Okay, that's going to give us a 0. So it's going to be 49 minus 6, and that is equal to a 43. Okay. All right, that's done. Okay. Simplification was definitely something that students were struggling with. So I do want to go through a lot of these. Inside, you want to start with multiplying. So 2, we'll rewrite the 16. 5 times 2 will give us a 10. Divide by 4. Again, we want to do inside, so 2 times 6. And then when you see something like this, you want to go left to right the way you read. So 12 divided by 4. And our answer here is 3. Okay. All right, again, we're working inside. Again, I'm going to double dip, and I'll work like those two first. So 2 times 5. 16 divided by 2 is 8. And then 2 times 3 is 6. Minus 2. It's just to save some space for you guys. 2 times 5. Again, we have to do the inside first. We can't just ignore that and do the outsides. So now we can do this outside because we see it first. Whoops. Wrote incorrectly there. That should not be a 6 anymore. That's a 2. So 20 minus 2 will actually give us an 18. Okay. A lot of the issues with simplifying and orders of operation I have found is just really people not taking their time. You definitely want to make sure that you're going through and you're reading everything. Let's change up the color. Why not? You really want to make sure that you are paying attention, that you're taking down some notes. You can't just free rein your way through the math. It's got to be a little bit of a and here again you can see when you don't write nicely you end up with some errors. Okay, so that's actually a multiplication. So I can do this at the same time. So 88 minus 3, and that 3 coming from the 6 divided by 2. So that gives us an answer of 85. Okay. All right. We're going to switch gears a little bit here, and we're going to do some division. When you see zeros like this, so you have 75,000 and you have 10, you actually just get to cancel out 1 0. 1 0 for every 0 you see. So the zeros cancel. So this answer here is actually 70. No more 70. It's 7,500. And that's it. You don't have to do any true division there. You can just use that shortcut. It'll work every time as long as it's that style. Okay. So here you want to take your bigger number because it's how much is 109 divided by 5. So 109 and divided by 5. Well, we know 5 goes into 10 twice. Okay. Bring down our 9. 5 goes into 9 only once with a remainder of 4. So your answer here is 21R4. That's okay. That's what EdReady wants. I'm going to show you another way to do it down here. I'll still show you the remainder answer, but you will see conventionally, if you were in my class and this was not an EdReady course, we would do this a little bit differently. This is good for the now, but eventually you want to write it a little bit nicer. So let me show you. So sometimes you just end up guessing like what looks nice. So 37 times 2 is actually 74. So that works nicely. Excuse me. And then you have 23 left. And then you bring down your 8. So you have 233. 233, 37 times 6 will give us 2s across the board. So 2, 2, 2. So that will give us a remainder of 16. So the answer EdReady likes to see is 26, remainder 16. And I shouldn't say EdReady, I should say EdReady at this point. Eventually, what these answers are going to look like, though, is when you see a remainder like this, you can actually write this as 21 4/5. Those are the same things. That is more mathematically nicer. It's more advanced. Okay, and then this one would be 26 16/37. Okay? All right. All right, next question says, and we'll use red for the apples here. Here's 1 apple, here's 2 apple, 3 apple, 4 apple, 5 apple, 6 apple, 7 apple, 8 apples. Look at that. Again, I'm finding another mistake because I I did it so quickly before and I didn't color code it. And then just because why not? Let's color in our oranges. Okay, so really your answer here is, it wants to know if Jasmine correctly writes the fraction of fruit that are apples, which of the following would be the numerator. So it should give you some options there. Obviously, they would give you the correct option of 1, 2, 3, 4, 5, 6, 7, 8. So 8 apples. Another option they would give you there would be the number of oranges, perhaps 15, who knows. But 8 is the correct number there. If you wanted to do the actual fraction, it would be 8/15 for the apples. And then, so then oranges must be 7/15 because together they would have to equal 1, and 8 plus 7 will give you the 15. All right. Portion that is not shaded. So this is a 3 by 5. 1, 2, 3. So 1, 2, 3. And then if you count across 1, 2, 3, 4, 5. So if you multiply those, you get what's missing. So it's a 3 by 5 grid, which means there's 15 total spaces. So if you were to do shaded versus not shaded, we would just come down here and recount these. So 1, 2, 3, 4, 5, 6, 7. So it'd be 7 out of 15. Okay. All right. Okay. We're going to move into multiplying and simplifying. Okay, so as I said, we're going to move over into multiplying and simplifying. Fractions. So you'll see that we're going to work with some whole number, or sorry, not whole numbers, mixed numbers, fractions, that kind of thing. I'm actually going to show you 2 different methods. So method 1. Okay. We would just take 5/6 times 2/7, and you're just going to multiply straight across. So sometimes it helps students if they write it out like this: 5 times 2 over 6 times 7. 5 times 2 is 10. 6 times 7 is 42. 2 goes into each, so that's going to simplify to 5 over 21. That is a valid option. It's a valid method. Here's a second way, and I tend to like it a little bit better. Okay, so if you notice from before, we simplified second, and some people would teach you that that's not like the only way to do it, but what they prefer, and you can see that it says multiply and simplify, but I actually like when we do the simplifying first, because then it lets us multiply smaller numbers and you're automatically right to your answer. So 5 and 7, of course, don't go into each other, but 2 goes into 6. So 2 is going to become a 1, 6 will become a 3, and now we're going to take 5 times 1 and 3 times 7, and that's going to get us to our 5 over 21 right away. A little bit smaller numbers to work with. Same end result, a little bit different of a process. Okay, so when you're dealing with these mixed numbers, what I like to do is I like to come in here and I like to change them into improper fractions. So remember, we're going to multiply and then add. So 2 times 7 will give us 14, plus 1 is 15, so that's 15 halves, times 5 times 1 is 5, plus 1 is 6, so that would be 6/5. Now, if we do method 1 again, it would be 15 times 6 would be 90 over 2 times 5, which is 10, which will give us 9. So let's do method 1 again just to show you. So 15 times 6 over 2 times 5. Again, this is method 1. So 90 over 10, the zeros cancel each other. You're going to get left with 9. What's nice that they do for EdReady is they kind of give you a hint here. They say it's going to be a whole number. Well, if they're telling you that, then probably you did something wrong if you don't get to that whole number. But method 2, let's see that again. It's going to be 15 over 2 times 6 over 5. Here, more things simplify, so 5 goes into 15 3 times. Okay, 2 goes into 3, or 2 goes into 6, sorry, 3 times. 3 times 3 over 1 times 1. Again, we get a 9. Okay, up to you on your method. That's my preference, is to do it method 2. So I wanted to show you it. Okay. All right. Simplify the answer and express as a mixed number. So 12 over 1 times 1 over 8. If we do method 2 on this one, which I'm not going to keep doing method 1 and method 2, you guys can choose what you like the most. I'm going to go with what I like. So a 4 goes into both here. So that gives you a 2 and a 3. So that would give you 3 halves. 2 goes into 3 once with 1 left over. So it would be 1 and 1/2. Okay, that is your mixed answer. Right. Next, we have a application problem. Let's go ahead and read it. The first thing you should do with any word problem is you need to read it as a human being first. Just read it, and then you need to go back and go, okay, what's important? So let's do the reading as a human first. A company has budgeted 5 1/3 hours to complete a project, with 1/4 of the time spent on the research. How much time does the company plan to spend on research? Express your answer as a mixed number. So here's what we need to figure out first. What's important? Well, we know it's 5 1/3 hours. Well, I mean, that's great to know, but how does that really help me? So what we're actually going to do is we're going to change that 5 1/3 into minutes. And then we can go backwards later on. So 5 hours, well, 1 hour is equal to 60 minutes. So if we take 5 times 60, we know that 5 hours is equal to 300 minutes. Okay. And then 1/3 of 60, that's actually equal to 20 minutes. So our total amount of time on this project is 320 minutes. So now we need to know how much is 1/4 of that time. So if our total is 320, we need to divide that by 4, because it's 1/4, right? So 1/4 of the time divided by 4, that actually gives us 80 minutes. And if we want to write that as a mixed number, then 80 minutes we can say is 1. And then what did we learn about 20 minutes? 20 minutes is 1/3 of an hour. So it's going to be 1 1/3 hours for research. Okay. Again, if I go too fast, just pause the video and you can take your time writing it down. All right. Okay, let's go ahead and read this one. A wall in Marcus's room is, well, let's use blue because that makes sense. Wall in Marcus's bedroom is 8 2/5 feet high and 18 1/3 feet long. If he paints half of the wall blue, how many square feet will be blue? So the first thing you have to figure out is you have to do your 8 2/5. I'm going to go ahead and change this to an improper. I'm going to multiply and add. So that's going to become 8 times 5 is 40 plus 2, so 42 over 5. And then I'm going to multiply it by 18 1/3. And I'm going to change that one too. It's going to become 55 over 3. I'm actually going to put it up here. 55 over 3. What's really cool is these simplify. So 5 goes into 55 11 times, and 3 goes into 42 14 times. So we just have to take 14 times 11. That gets you 154 feet squared for our area of our wall. And then now you just have to divide 154 by 2 because it says he's painting half the wall. So he's going to paint 77 feet squared. Okay. Or 77 feet squared will be painted blue, however you would want to write that there. All right, the next one takes us back a little bit to our, it's like an application of the rounding, and we're rounding to the nearest 10. So you actually want to look at the ones place for everything. So your total will be 1,270 miles. Day 1 will be 420 miles. And day 2 is 380 miles. So if we take and add 420 to 380, we actually get 800. Okay, if we take 1270 and subtract 800, we will end up with 470 miles left to drive, roughly. Okay, so Marcus has a long day ahead of him. And I don't know if I would go to that family reunion, but maybe there's nothing really for him to do in Wichita. And if you look up the history of Wichita, he's probably better going to Charleston. All right. A snack company can pack 16 granola bars in a box. How many boxes are needed for 800 granola bars? This is just going to be a division problem. We're going to take 800, see how many times 16 goes into that. Well, a good place to start would be 5, and that actually is nice because that is 80. And then when you have 2 zeros, then zeros out, all that is left. So it would be 50 boxes are needed. Okay. Same thing, but a little bit different for avocados or what, like green. We'll use green. So we have 360 crates, and then we have 8,640 total avocados. So we're going to figure out how many avocados are in each crate. So what's interesting is you could actually, if you wanted to, cut off the zeros on both of these. We're not going to, because it's fine. So I actually started with a 2 here, and that helped me out. So 360 times 2 is 720. This is going to be a little weird. I have to write it a little weird. So you have 144 left, and you bring the 0 down. And then I tried a 4, and that actually worked perfectly. So that means that there are 24 avocados. Avocados per crate. Okay. All right, we are almost done. I think there's, well, that's done. I think there are 3 questions left. Yeah. Okay, so this one was interesting on EdReady. It says do not include the $ in your answer, but then when it showed me the answer, the $ was there. So I guess if you get this one wrong and you think you have it right, go ahead and try it with the $. But I mean, it specifically tells you not to include it, but I can show you guys it does include it themselves, so I don't know. It says Dominic's 3 daughters want to take gymnastics this year. It costs $80 per month per child. So first off, if he has 3 students, 3 times 80 will give you $240 a month. and then we're going to multiply that by 12 because there are 12 months in a year. So that will give you $2,880 for the budget. Okay. All right. Those of you that were struggling with the geometry for the circles, please go back and watch some of my other reviews. I did not pull the circle questions yet. Maybe I will for next week's review. But for this week, I just stopped here. I'll give you all a moment of my statements in a minute. Let me finish this. Shown below is a blueprint for a kennel. What is the total length of fencing to enclose the kennel? The total length needed is blank feet. You're just going to you can do this two different ways. You can either multiply each of these by 2 and add them, or just add them twice. So 13 and 13 give you 26. 24 and 24 will give you 48. If we add those together, we get 74. So 74 feet of fencing. Okay. All right, last question here says, Jackie is installing a rather large rectangular swimming pool in her backyard. It measures 25 feet by 50 feet. What is the area of the pool? I'm just going to take 50, multiply it by 25, 0, 250, 0, 0, 10. So that's a 0, by the way. So then you get a total of 1250. So 1,250 feet squared. Very large pool, very expensive. Okay. All right, that is that. So if I were to give you guys some statements about what I feel is happening, some students are plowing through the EdReady, they're hitting their 90 points, and they're retesting. You need to take the test on the EdReady. Don't be afraid of doing that. Those tests are where I pull your missed or skipped questions. And right now, I just don't have any more questions to pull. So I need you guys to get in there and don't be afraid of taking those tests. Take them. I know you'll be productive and you'll be successful no matter what, because if you're practicing the math and doing the math, then you know that's going to be a benefit to you no matter what. So I need you guys to do those tests because that's where I pull my problems from. All right. Good luck to everybody today, and we will have another, I hope, long review next week. And if not, then I'll let you know. Tomorrow's check-in, you guys can email me if you need one. If not, I'll be here. Email me. Have a great day. Bye.